This question is a hypothesis test for a population proportion, and I would like you to pause and read the question first. And once you have read the question, we're going to look at it and we're going to pick out the things that we know. We see the number 843 patients, so that is going to be our sample size. N equals 843. The next number we see is 20. 20 out of the 843 patients complained of flu-like symptoms. So that's our X. X is 20. 20 successes. Suppose that it is known that 2.1% of patients complain of flu-like symptoms. So that is a proportion, and that's going to be our P naught. P sub 0 is P naught, and it's 2.1%. So as a decimal, we write that as 0.021. And that's all the numbers. Nope, they give us the alpha. Next number they give us is alpha is 0.01. Okay, that's all the numbers they give us. Now, they do tell us that we are looking, is there sufficient evidence to conclude that more than 2.1% of this drug's users experience flu-like symptoms? Okay, so more than, we know that that is going to be greater than. So first thing, let's find out if this can be assumed normal. First thing we have to look at is random sampling. And that should be given to us in the question. Let's see, random. Okay, next thing we need to know is that the sample size is less than 5% of the population size. So let's just assume that there are, 100,000? 100,000 patients, and 5% of that is 5,000. So let's say 5% of 100,000 is 5,000, and we need to be smaller than that, and 843 is certainly smaller than that. And every time you see a question like this, it is going to be smaller than 5% of the population. If not, we can't call it normal. We can't move on. So this was our sample size is less than or equal to 5% of the population. And then they're going to ask us for a calculation for this. N times P naught times Q naught, which is 1 minus P naught. Okay, and that must be greater than or equal to 10 for us to assume normality. So let's plug those numbers in. Let's see. 843 times 0.021 times 1 minus 0.021, and that is going to give us 17.331237. Okay, so they're going to ask us to round it to one decimal place. Here we go, 17.3. And is that greater than or equal to 10? Yes, that is greater than 10. Okay, so now we can assume that this is normal and all of the requirements are satisfied. All right, next let's write our hypothesis, our null hypothesis. H naught is that the proportion is 0.021. Okay, they told us that from before. That's our status quo. That is our null hypothesis. Next is our alternative hypothesis. And in this case, they have a suspicion that our proportion of the flu-like symptoms is greater than 0.021, or at least they want to make sure that this is maybe not the case and that we can stay with the status quo. So since it's normal, we are going to find our z test statistic. Okay, Z naught. And we're going to do this using a formula. And here's the formula. It's going to be P hat minus P naught over the square root of P naught times Q naught over N, sample size. All right, we have all of these numbers except for one. We don't have the P hat. So let's come over here. Let's find our P hat. Right, your proportion is the number of successes over the total. So it's X over N. And in this case, it is 20 over 843. Now, I'm going to do that in the calculator, but in the real statistic, I'm going to put it all together because I have a fancy calculator where I can put it all together, and I'll show you that too. But if I want to look at 20 divided by 843, that is going to be 0.0237247 9, and on. Okay, can you round this? Yes, you can round this. You're going to get a different number, but your homework software should accept it whether you keep it as the fraction or whether you round it 0.024. All right, so in my calculator, I'm going to put it in like this. I am going to make it a fraction up here. This is going to be 20 over 843 minus 0.021 over the square root of, in the numerator I have 0.021 times 1 minus 0.021 all over my N sample size, which they told me was 843. Okay, now I'm able to put all of this into my calculator. And I can find my test statistic, my Z naught, and it's going to give me 0.55175492. Okay, rounding that to 2 decimal places, 0.55. Okay, now if you do this and you use 0.024, right, and you use this number up here, you're going to get a z-test statistic of, let me put this in green, 0.61. The next thing they're going to want us to find is the p-value. So let's use this z-statistic of 0.61. Okay, assume we rounded. Now, for the p-value, I like to, at this point, draw my bell curve, and I like to see what I'm talking about. I know my z-statistic, so this is normal, so we have 0 right here. Inflection point is 1, so 0.61 is going to be somewhere around here, 0.61. Okay, and this is greater than, so we're looking at this side over here, okay, this area to the right of the 0.61. Now, my normal table is only going to show me the left side of the shaded graph. So the area here is the same thing as the area to the left of negative 0.61. Okay, that's going to be my p-value. So what I can do is I can look on the table. If I go to a normal table and I'm going to look for negative 0.6, so I come down here, negative 0.61, right here, 0.27093. Okay, that's my p-value. 0.27093, which is going to round to 0.271. And now let's interpret the results. I'm going to compare my p-value to my alpha. So p-value is 0.271, alpha is 0.01. And in this case, my p-value is greater than alpha. And if that's the case, I do not reject. Do not reject the null hypothesis. Okay, we got to go with the status quo. This would have to be so small, it would have to be smaller than the alpha for us to be able to reject the null hypothesis and to be saying something new. But we can't do that, so we do not reject the null hypothesis. There is not sufficient evidence at the alpha equals 0.01 level of significance to conclude more than 2.1% of the users who take the prescription drug complain of flu-like symptoms. Okay, and in the answer here, they will ask you, you'll say more than, and then we go back to the 2.1%. All right.